Hi, this is my design pattern video, and today we're going to be breaking down the composite design pattern. So this design pattern is specifically used to create hierarchical structures like tree forms, where you have branches coming from a certain node which has children. So parent node, children nodes, all of that to define that you would and to be able to iterate through it and do what you need to do and traverse the tree. You would like some uniformity to where, just based on what type of node it is or what type of parent or children it is, you don't want to have to completely revamp your interaction with it, right? You would like it to be the same. Like when you go from one node to the next, that process is the same. So, using that basic analogy, we can kind of see the benefit of that uniformity and how it's actually executed in this example code here. So before we get into the example code, let's dive into the three main roles that are required to be able to, that have to be implemented to be able to qualify as a composite design pattern. So let's start with the base class that actually defines that uniformity for all the subsequent nodes. So this base class is a common interface that's established using virtual functions, right? Uh, that will be inherited by individual objects and composite objects. So these individual objects are called individual objects because they don't have any children nodes, right? They don't have any children objects, so they don't store or maintain a list of other components. Composite objects, on the other hand, do maintain that list and have children objects or children components. And so these three roles, these three parts have to be within the code definition to be able to qualify as a pattern, as a composite design pattern. We have to define these three. So let's get into the actual base class, right? This is what's, again, defining the uniformity. And so you'll see certain virtual functions that are defined here. To start with, we have the set parent, which, as you can see, as you can maybe kind of guess, would be implemented by this composite to be able to assign children nodes a parent, right? And then you can get the parent node of a children of the children, and then you can see we have the add and remove virtual functions. So this would be able to that list that I was talking about in the composite. That list can be updated with this add and remove, where you can add components to the stack that's being stored or remove. And you can see it's component. It doesn't say it doesn't define an individual or a composite. It's not separate. Component is just component. And now you can see here, here's a Boolean asking whether it's a composite, so whether it's actually storing children. And the default is false. And then you have just a random, just an operation, right? Just a method called operation. And obviously, this can be defined very differently for the classes that it will be inheriting from this component, as we'll see here. So now we're going to jump into the individual component, which is titled leaf. And this leaf node definition, all it does is it just defines that operation method. And what this method does is it just returns a string titled leaf. So all these other methods that were defined here, they have not been implemented in this subsequent class. They don't have to be. But this operation is implemented. And so what that allows us to do is to be able to call this function, say you pass this leaf in and you tell this node without knowing whether it's a leaf or a composite, as you'll see, to do this operation, and it will return something, and it'll work because again, there's both of this leaf and this composite, as we'll jump into, inherit from this component class, the base class. So let's dive into the actual composite, which is again has children and is storing a list of children nodes or children objects. So here's the list defined here, and here it's implementing a lot more functions, right? It's implementing the add. It's overriding the add and remove on its own. So it's doing exactly what you can kind of guess from it, right? It's just adding the components. It takes in a component and then it adds it to the list that it's storing. And again, this component is it can be another a composite, or it can just be an individual leaf, right? Doesn't matter because there's uniformity. It's all the base class, which is the component that's defining that interface to be able to interact with these objects. And then there's this component returning whether it's true or not, which it is, because we are defining a composite class. And then here's its version of the operation function. And so here, it's actually iterating through that list of children that it has. And for each child, it's calling its own operation function and then printing that and seeing what that output is. And so all of this, again, it's just taking the component. So the child can be either a composite or a individual leaf. And all it has to do is just call that operation because it's defined for both types of classes. Now here's a client code, a user interface, I guess you could call, that takes in a component and then again uses that operation function. And here's another code that is able to take in a component, see if it's composite, if it's not, because again the default is false if it's a leaf, right? It'll say it's not, and then this won't run if it is. If it is a composite, then you can use that add function, and it'll add another component. And then it prints the result of the operation function for that component. And so you can see here there is so much uniformity to where we don't have to interact with leaves or composites differently, right? So a good analogy would be to think of a file system that you have established. And so when you go into, let's say, your Finder, and you see there's in a folder, there can be files and another folder within, right? You don't want to, when you're interacting with these folders and you're trying to open, let's say, a folder or a file, you don't want it to be triple click for a folder and double click for a file. That just doesn't make any sense, right? That interaction wants to be the same just for efficiency and for ease of use. So it's a double tap to open the file, it's a double tap to open the folder. In that same way, it's the same operation function to run that operation, and it's the same for a leaf or for a composite. And here's a really quick example of what not to do. Again, you don't want to define without the base. There's no base class here, and the leaf and the composite functions are all defined on its own. So you have to call these and interact with these individually, and that makes it, um, it's just not convenient. And so providing that uniformity and employing that composite design pattern when you want to um, have a tree structure and um, iterate through them very easily is highly recommended. That was a little long-winded. I hope that was useful, and thanks for watching.